we have with us Mr. Maninder Saini, who will deliver two lectures today. The first one on vehicle performance estimation, and the second one, new transmission technologies. So Mr. Saini has a rich experience in design and manufacturing in automobile sector. He worked with Agri-King tractors and equipments, where he was responsible for the complete design of transmission for 40 HP and 50 HP tractors. He was also involved in manufacturing of gears, shafts, and other dynamic components. For the last 4 years, he is working as transmission design engineer with SML Isuzu, that is Swaraj Mazda Limited. Earlier it was Swaraj. Now it is, I think it has been taken over by Isuzu. So now it is called SML Isuzu, based near Ropar in Punjab. So there he is working with the transmission team, and he is also taking care of transmission as well as differential for new product development. So I now request Mr. Saini to please take it.
Myself, Maninder Saini, as my introduction is always over. So today I am going to deliver a lecture on vehicle performance. So what is, all topics are discussed side by side. What is engine, what is gearbox, what is differential. The vehicle integration team taking care of the cabin, suspension, all that elements. But no one consider this system as a whole. So for designing a vehicle, we have to consider the whole system. By considering the whole system, we are going to design individual parameters. First of all, engine, transmission, and these kind of things. So I will going to explain this topic, particular topic, a rare topic, vehicle performance estimation or vehicle estimation. So as introduced, I am Maninder Saini. So now the question is, why vehicle performance estimation is required? Why vehicle performance estimation is required? Why vehicle performance estimation is required? First of all, when we are going to design a vehicle, we should know what we are going to design. We are designing a motorcycle, we are designing a car, we are going to design a truck, or what vehicle we are going to design. So it is a clear picture in our mind that what vehicle we want to design. So for that vehicle, we need particular parameters. We need to set particular parameters. So first of all, by not doing blunders in design, we are calculating every parameter. We calculate overall vehicle performance by a method, and based on that method, we select the engine, the transmission, whatever. I will explain it later. So is it clear? Second one is the types of vehicle. Here we classify the vehicle in basic types. This is types of vehicle. Passenger cars. In passenger cars, our engine are generally less than 75 kilowatts power, and this is a passenger car segment. This is commercial segment, and other application of vehicles are agriculture tractors, construction vehicles, and special vehicles. Army vehicles are using 4x4 transmission. The special vehicles, the Swachh Bharat vehicles, which are going to introduce by our government within few months. So this is basically the type of vehicle. What vehicles are trend set by the market, which are designed in our recent scenario. Now, as I discussed, suppose I select I am going to design a motorcycle. So what will be the parameters for motorcycle? What are the basic parameters for motorcycle? So this includes a powertrain. We call it a powertrain. The engine, transmission, differential, and tire is completely a powertrain, a power plant which is going to deliver the torque and power requirements of the vehicle to a vehicle. So in this, engine is our main component which is going to deliver power to our vehicle. And second one is the transmission, which distributes that power for our torque as well as speed requirements. And the third component is differential, which distributes the power at 90 degree, as well as it also acts as a second transmission for the vehicle, because it increases the gear ratio which is taken from gearbox. So then the tire. So what happened if my tire size increase? Can anyone explain? What happened if my tire size increase?
It will consume more power.
It will consume
More power
why?
because the resistance effect of the tire that will increase.
No, when the tire size increase, its circumference increase. When circumference increase, the frictional force is a point force, which is not. If I go board please. So this is a small tire. This is a big tire. When my circumference increase, my radius get increased with the increased rate. But when I talking about at this point, the friction is going to act only in this particular area. When we integrate this particular area, it is not as much a big difference in the frictional resistance due to point contact. When we integrate this point contact, from small to big, then it is not as big significant difference. So the significant difference which is coming is R. So when radius increases, the circumference increases, and this wheel is going to deliver n RPM, and this from differential. From differential it will get n RPM, and from differential it will get the same n RPM. With that n RPM, it will cover more distance. It will cover more distance. So its speed will increase. But due to R, the torque reduces. Suppose this is delivering TR. The value of torque given by the engine for the both wheels are same. Torque is equal to force into perpendicular distance. So when this comes under this with the increased R, the torque increase. Clear? So these all are very unknown factors for vehicles which are going to be designed. For that, we have to estimate each and every parameter. Clear? Now, how do we come to know about the specification of each element of the driveline for a particular vehicle? As I explained earlier, this drivetrain include engine, clutch, gearbox, rear axle, and tire size. So when I am going to design a new vehicle, I do not know anything about any specification of each component, each element. I do not know what will be my engine size, what are my requirements. So vehicle power and torque requirements. So I will calculate the vehicle power and torque requirements. Suppose I am going to design a truck. I will calculate the truck power and torque requirements. If I am going to design a car, then I have to calculate the car power and torque requirements. What torque and power is needed by the vehicle to accelerate in particular conditions. Clear? So now I define my problem, vehicle power requirement. What will be my vehicle power requirement? This is my problem. First of all, we have to define the vehicle specification. The first specification is GVW, gross vehicle weight. This includes each and every component in the vehicle with passengers, with payload, everything. Complete package with which the vehicle is going to accelerate with his powertrain. The complete GVW, complete package. Even with a needle in vehicle, we calculate the vehicle's performance, powertrain requirements. Clear? And power to weight ratio requirement. Then what is a power to weight ratio requirement? Power to weight ratio requirement is basically, if I ask a question that you all have cars with you, you all have vehicles with you, you are seeing trucks and trains are over there. So if I ask about what is a power to weight ratio, the power to weight ratio is that what power is given by the powertrain to a unit weight. In passenger cars, our power to weight ratio is more. In truck segment and all that commercial segment, our power to weight ratio is less, because we optimize that power to accelerate that particular weight. But in car, we are using as for luxury and as for fuel efficiency. So the power to weight ratio at this segment is little bit high, and I will explain it in further slides then why we kept that power to weight ratio in car or passenger segment little bit higher than the commercial vehicle segments. Clear? Then the next question is the frontal area of vehicle. What will be the frontal area of vehicle? And what are the impact of front area of vehicle? Here the aerodynamics comes into account. If I am going to design a truck, then its frontal area is comparatively more than cars. If I'm going to design a motorcycle, then its frontal area is comparatively less than cars. So by considering that frontal area, we have to estimate the vehicle performance. That is also a factor. Clear? And then maximum inclination that vehicle can climb. As a government rule to design the roads, the maximum inclination in the roads is up to 7 degrees. The maximum inclination is up to 7 degrees. But in drastic conditions, for example, in mining application, in tractor application, other application which are not specialized or standardized, we have to increase that gradability. Because if we design our vehicle as per government norms, then people will ask us that my vehicle is not going to climb up to 10 degrees. Then what we will going to do? That will be a big problem for us. So we study the complete vehicle requirements, that what the maximum inclinations can be achieved in our regional areas. So that's why the vehicle are designed for a particular region is not sometime preferable at another set of conditions. For example, the car is very famous in Germany, will not make a good contribution in India. So that's the basic reason. We have to specify our requirements first. If I am going to make my pant, I will make it according to my requirements. So these are the basic requirements. Then that inclination is basically based on field study. Suppose we assume a point that my truck is loaded in loaded condition, and suddenly a stone come in the way of the truck. Then what will happen? There is no inclination, but a threshold is created in front of truck. He has to produce that much amount of torque and power to overcome that problem. Inclination is produced, but there is no inclination in the road. Clear? So that is our requirement. Then maximum speed vehicle can achieve. What will be the maximum speed on which I am going to drive my vehicle? Suppose we are having a smaller engine, small engine. We are talking about a truck segment, and now we have a small engine. Suppose this is a constraint, suppose. And now, but my torque requirements on wheels are more. I will use the bigger gear ratios to achieve the torque requirements. But what about the speed? From where I will get the speed? Clear? From where I will get the speed? So this is one of the specifications which are again freezed for a particular vehicle torque requirements. Then driving conditions. Driving conditions are those that in what area you are driving your vehicle. For example, if I am driving my vehicle in Rajasthan area and then I take it to Lahore, after that I will take it to Leh, the air density changes. At higher altitude, the pressure reduced and air density changed due to moisture content and other content. But at Rajasthan, the conditions are very different. No moisture in the air density is less. So we also have to consider their parameters to calculate the vehicle torque requirements. Air density with increased moisture content, air density increases. With the decreased moisture content, air density decreases. If I take an example that a vehicle is going to pass through a dense environment, then it will consume more power. When his vehicle is going to accelerate in dense environment, it will consume more power. when a vehicle is going to accelerate in a less dense environment, it will consume a less power. Clear? So that are the basic specifications which we have to freeze before designing a vehicle. Then these are the basic boundary conditions which we are.
Excuse me, sir.
Yes, sir.
सर एयर डेंसिटी कैसे अफेक्ट करेगी पावर पर, ये एक्सप्लेन करना फिर से.
सर जैसे अब हम सिंपल एग्जांपल ले लेते हैं सर. हेलो सर, हम सिंपल एग्जांपल ले लेते हैं कि एक तो मैं रोड पे भाग रहा हूं सर, और एक मैं मक्की के खेत में भाग रहा हूं.
जी.
तो इन विच केस माई स्पीड विल बी मोर.
रोड
on road. So that is the air density basically. Clear? Clear, sir?
Okay, sir. Thank you.
Thank you.
Yes, sir. Yes, sir.
Thank you, brother. So based on this boundary conditions for vehicle, power and torque requirements of defined aggregate is calculated. The different angle of inclination, power and torque requirements are based on the following factors. So अब हमने ये freeze कर लिया that we are going to make a particular vehicle. On what factors, on what conditions the vehicle is going to perform. Then we have to give that much of power to vehicle to perform. Clear? On what factors we are deciding the power of the vehicle? On what factors we are going to decide the power and torque requirements of the vehicle? Clear? So these are the basic factors on which the vehicle power requirement is calculated. First one is wheel resistance. Second is air resistance. Third is gradient resistance. And fourth one is acceleration resistance. I will elaborate these resistances in the further slides. So these are the basically parameters which are required to give the power to the vehicle. As theory is the 85% simulation of 100% practical situation. So we are estimating the entire situation 85%. And after performance, we will judge on what platform we are standing to achieve the 100% results. So this is the basic estimation to give the power and torque requirement to the vehicle. So first of all, the wheel resistance. What is the wheel resistance? The wheel resistance comprises the resisting forces acting on the rolling wheel. It is made up of rolling resistance, road surface resistance, and slip resistance. So as in the figure, there is a wheel. And what is the wheel resistance? So wheel resistance is the resistance offered by the wheel when the vehicle is going to start, or the vehicle when vehicle is in accelerating conditions. Suppose that my tire is inflated and it is having less air pressure than my normal condition. Then what will happen? My tire will little bit bumped. Due to this bump, another reaction force comes into action. This resistance force comes into action with a little bit shifted from center with E. Clear? When this is shifted with center E, then vehicle will need more power and torque requirements to accelerate in that conditions. That's why the specifications are there. Maintain your tire pressures. Clear? And after that, the second thing is what, as I explained you earlier, that with what radius the tire is generating force with a required torque. So this is basically, the figure shows force and torque acting on wheel. The integral of pressure distribution over the tire contact area gives the reaction of force R. It is the same as wheel road GR. Because of a symmetry pressure distribution in wheel contact area of rolling wheel of the point of application of reaction force R is located in the front wheel axis by the amount of eccentricity E. Some board wheels. So as clear from the figure, as we distribute these forces, this is the torque requirement. Clear? And this torque requirement is equal to Fu into R dy n plus R into E. Why? Because the torque is in clockwise direction, TR is in clockwise direction, and the acting forces Fu and R is in anti-clockwise direction. If we see it is in anti-clockwise direction, and the E and R is also in the anti-clockwise direction. To satisfy that equilibrium, we comes with this equation. So this is the equation which we derived. TR is equal to Fu into R dynamic and R into E. So after that, for wheel rolling without driving torque and brake torque, TR is equal to 0. Suppose my vehicle is not producing any torque. My differential is not giving torque to my wheels. What we are simulating? We are simulating the wheel resistance. So when we get the wheel resistance, when that resistance deaccelerate the vehicle with time, then we calculate that wheel resistance. If we remove that generating force from wheel, then with some effect the wheel will deaccelerate. थोड़ी देर बाद व्हील डीएक्सेलरेट शुरू होना हो जाएगा तो वो रुक जाएगा थोड़ी देर बाद तो on what factors that deacceleration depends? It's on wheel resistance. So in ideal condition, if there is no wheel resistance, then we simply accelerate the vehicle and put in on a cruise, and it will remain the same on the entire cruise. On what forces that vehicle deaccelerate, we have to calculate that. So this is the wheel resistance. ਅਸੀਂ ਵਹੀਕਲ ਨੂੰ ਇੱਕ ਵਾਰ ਇੰਜਨ ਸਟਾਰਟ ਕਰਕੇ ਛੱਡ ਦੇ, ਜੇ ਰੈਜ਼ਿਸਟੈਂਸ ਕੋਈ ਹੋਵੇ ਨਾ ਤਾਂ ਉਹਨੇ ਸਿੱਧਾ ਭੱਜੀ ਜਾਣਾ, ਤੇ ਰੁਕਣਾ ਕਿਤੇ ਹੈ ਨਹੀਂ, ਜਾਂਦਾ ਰਹੇਗਾ। ਤਾਂ ਕੋਈ ਤਾਂ ਰੈਜ਼ਿਸਟੈਂਸ ਹੈ ਜਿਹੜੀ ਉਹਨੂੰ ਰੋਕਦੀ ਹੈ। So we have to calculate that resistance. So from here we put the torque is equal to 0. We eliminate the torque from the wheel. When we eliminate the torque from the wheel, it is 0 here, and Fu into R into E. From here we calculate minus Fu is equal to Fu into R by N is equal to R into E. Clear? Generally, what we are going to calculate? We are calculating the wheel resistance. Then the circumferential forces Fu is equal to rolling resistance forces Fr roll. Given these assumption on level surface, R is equal to GR, and then therefore, so what this particular sentence indicates, when a vehicle is on level road, level road. So with the inclination, if my vehicle is in inclination, then its gravity shifted from its center. In that condition, we have to work with another set of equations. But on plane requirement, we are considering that vehicle is on plane road. So in this case, the minus Fu become the R roll. So this now equation leads to minus Fu is equal to R into E divided by R dynamic. Why this force is negative? Because this is a deaccelerating force. Clear? The dimensionless property factor Fr is designed the rolling resistance coefficient. Then another coefficient come into action. So here is a rolling resistance coefficient. Here is E and R dynamic. The E corresponds to distance. Unit of E will be distance, and the unit of R will be distance also. By cancelling distance with distance, it is a unitless, dimensionless factor. This is a coefficient, rolling resistance coefficient. When this rolling resistance coefficient is multiplied by the GR, this R is a force on plane road which is acting opposite to GR, the load of the vehicle. In a plane road, this GR will become R on a plane road. So in this condition, my R will become GR into E divided by R dynamic. This is a frictionless coefficient. This is a rolling friction resistance and a coefficient. So these are the dimensions which are based on experimental results for different rolling friction coefficients. It depends upon the nature of the road. First of all, the tires and components of tires, pneumatic or solid rubber tires, working temperature, the weight of vehicle, the speed of the vehicle. Now for nature of the road, for example, we are taking example of nature of the roads, then we have different kind of roads. Smooth thermic track.
Hello.
Yes.
Hello, sir. Actually, I'm from JIT. So I want to ask: is inflation pressure of tire is depends on contact to road surface also affect wheel resistance?
Yes, sir. Definitely.
Then what is the pressure, sir, which we include in the tire?
What is the pressure?
What is the value of the pressure? that we use.
Sir, in that condition, we have to inflate the tires up to when our R is equal to GR.
Thank you, sir.
Thank you. We are assuming the ideal conditions. As I say earlier, we are estimating the 85% estimation of practical situations. The designing is only 85% estimation है, बाकी जो कुछ होएगा वो तो practical result है दसणगे जी.
I want to know what is the GR.
Sorry.
I want to know what is the GR.
GR is the load of the vehicle distributed on that particular tire.
Okay. Thank you, sir.
So now nature of the surface, road surface. Road surface will be our cemented road also. Road surface is concrete road, as we are traveling on the concrete road, and the rough good concrete road, as we are seeing usually in our India, rough good concrete surface. So good stone paving, ਜਿਹਨੂੰ ਆਪਾਂ ਬਜਰੀ ਦੀ ਸੜਕ ਵੀ ਕਹਿ ਦਿੰਦੇ ਆ simply, no varnishing over there. Bad worn road surfaces ਘੱਟ ਆ ਜਾਂਦੇ ਆਪਣੇ simply, ਜਿੱਥੇ roads ਹੈ ਨਹੀਂ. So these are these, we have to consider all these things. So for that, we are done with a set of experiments, and on that set of experiments we establish the coefficients for friction. Clear? Then the wheel resistance. Now FR please go. Now this whole set of calculations was previously associated on the plain road. Clear? Was previously associated on the plain road. What will happen if the road is inclined? Then what will be my forces? Cos theta. Why cos theta? Because the cos theta is the downward component. mg cos theta is the downward component, not sin theta. If I have to calculate the forces which are required to accelerate the vehicle in inclination, then I will take the sin theta component. Now, what the mass is acting, gr, what is the value of gr, f? As discussed earlier on question here, that what will be the value of gr? Gr is the value of the mass on that particular tire. So that mass on a particular tire at inclination will be included in cos theta. Clear? That component of mass will act downward. In previous cases, gr is acting in this area, and now gr is acting with inclination, which is multiplied by the cos theta. Clear? Now, where m is the mass of the vehicle, the acceleration due to gravity, g is the acceleration due to gravity. Why it is included? Because mass is a independent quantity. Weight of the vehicle, and weight in SI unit, weight is a independent quantity. To convert that weight into force, gr, To convert that weight into force, we are multiplying this weight by acceleration due to gravity. Clear? So now this all satisfied. Fr, force, and R, resistance. Force into perpendicular distance is equal to, this is the force. Fr is the friction of rolling resistance. On what road the vehicle is accelerating? Is it on a bad road? Suppose we are accelerating a vehicle in inclination on a sand surface. Then what will happen? Our power requirements will be different. If we are going to accelerate a particular vehicle in a good concrete condition, then our power requirements will also differ. Clear? So for that, we have the coefficient of rolling resistance, which I have explained in previous slide. These are the values of coefficient resistance for different tracks. Clear? Now everything is clear? Now the air resistance. So the air resistance depends upon the 0.5 into rho into area into CD into V square, where FL is air resistance, which we are going to calculate. A is the frontal area of the vehicle. As I discussed earlier, if the frontal area is less, then I have to work against the less air resistance. जिन्ना मेरा frontal area घट रहेगा, उन्ना मैनू घट जोर लाना पड़ेगा अगे जाने लई. जिन्ना मेरा frontal area ज्यादा रहेगा, उन्ना मैनू अगे जाने लई ज्यादा जोर लाना पड़ेगा. So this is how frontal area acts, and CV is the coefficient of the drag. This further depends upon the experimental conditions, that at different situation what are our drag coefficients. कि मेरा moist air ते drag coefficient कितना रहेगा, low moist air ते drag coefficient कितना रहेगा. Clear? Then V is the vehicle speed. Now when my vehicle starts, then there is no air resistance. No air resistance. We have to work. We are not working on air resistance. No air resistance. But when my vehicle is accelerating, then air resistance comes into action, and it will increase with the increase in velocity. As my velocity increasing, my air resistance will increase with the relation V square. So when we are accelerating, actually we are requiring more power. In case of passenger car, we are requiring more power when we are accelerating. That's why my power to weight ratio is more. But in truck segment, when we are accelerating, we do not have that much of requirement to accelerate in particular conditions, because trucks are meant for commercial vehicles are meant for the load distribution all over the country. So they generally operates between 60 to 80 kilometer per hour range. So they doesn't need that much of calculations. Clear? Now the next thing is air density. What is my air density? This is generally a general condition. Now the values of CV for different conditions. For motorbike with ride, the CV will be 0.5 to 0.7, and the approximately frontal area for a general motorcycle is given in this table, 0.7 to 0.9 meter square. And by multiplying these two factors, we are having on a journal figure 0.4 to 0.5. These all are journal figures. Open convertible, खुलियां जीपां, जो कुछ भी जो आप जनरली देख रहे हैं. Lamborghinis, coaches, trucks with trailer, agricultural vehicles, tractor हो गए. Journal, it is a journal figure. But for specifically, we have to make a project to calculate the frontal area of the vehicle. If we are developing something new, सारा कुछ नए सिरे तो बना रहे हैं, then we have to take up a project लेना पड़ेगा जिदे च ਆਪਾਂ ਇਹ कैलकुलेट करांगे कि vehicle ਦਾ frontal area कितना है. Clear? But these are general requirements for references. Then gradient resistance. What is the force required by the vehicle to climb a particular gradient? So this is the F into mg into sine theta, as I explained you earlier. Clear? At that time, the frictional resistance over there in terms of Fr, in this case, no frictional resistance is there. And this sine theta component, is directly multiplied by the weight. This much force is required to accelerate the. Clear? Now this is the gradient resistance. Fr, gradient resistance, the mass of the vehicle, acceleration due to gravity to convert the mass into force, and the angle of the gradient on. Now the acceleration resistance. What is acceleration resistance? When we accelerate our vehicle, then our vehicle have a certain inertia. Our vehicle have a certain inertia. To get our vehicle out of that inertia, either acceleration or retardation, we have to put the extra effort. Suppose I am accelerating, I am in steady state, I am driving in steady state condition, then I am going to accelerate my car. Then what will happen? My car gears and all the rotating components are rotating with this specific inertia, particular inertia. When this particular inertia is further accelerated, then it will give a resistance. Either entire mass of the vehicle or the dynamic components. Engine, transmission components, the differential components, the axles, the wheels, whatever which contain mass will have a inertia. Clear? Now acceleration resistance, Fa, the rotational inertia coefficient. Again, what are the masses? What are the different masses? What are their coefficients are over there? This is a generalized coefficient. And mass of the vehicle, acceleration of the vehicle. Now total driving resistance. What is the total driving resistance? What is the total force which I required to give a vehicle to accelerate, either in plane condition or in inclination? ਇੱਕ ਗੱਡੀ ਨੂੰ ਚੜਨ ਦੇ ਲਈ ਕਿੰਨੀ ਫੋਰਸ ਰਿਕੁਆਇਰਡ ਹੈ, ਆਈਦਰ ਪਲੇਨ ਕੰਡੀਸ਼ਨ ਚ ਜਾਂ ਕਿਸੇ ਪਹਾੜੀ ਕੰਡੀਸ਼ਨ ਚ. We are going to estimate this thing in by adding up all these forces. So together with the equation, this may be expanded to, this is mgfr cos theta is our wheel resistance plus our air resistance plus our gradient resistance mg sin theta plus our acceleration resistance. सर यहाँ पे ना जब मैं स्लाइड्स बना रहा था ना तो इसमें 1/2 आ रहा था. drag.
drag में 0.5
हाँ, sorry.
ड्रैग स्टडी करते हैं ना
हाँ.
सर, उसमें 0.5 मल्टीप्लाई करना पड़ता है स्टैंडर्ड कंडीशन।
Sir, this is actually a relation. The relation, अब हम क्या करेंगे? We are experimenting certain set of condition. That my suppose that this is my air resistance. We are calculating generally what we do. We accelerate our vehicle up to 120 km/h. Then we put the entire drivetrain off. Then we will study what time the vehicle will take to reach up to a certain speed. Then we study the different set of conditions at 100 km/h, at 80 km/h. Then by studying this, we develop a relation empirically. So on that value, we have to put 1.1/2 to compensate, because we journalize our experiment by equations. What we are doing with equation? Why we make equations? We are journalizing our experimental facts, that we do not have to repeat that experimental facts again and again and again. So we make a journalized version, that is known as equation. So based on that particular behavior, this equation is established. Clear? With steady state motion, acceleration is equal to 0. Suppose I am driving with continuously 60 km/h from entire 1 hour. Then my acceleration is rate of change of velocity. If I am continuously driving with 60 km/h, then my acceleration is 0. I am not changing my velocity. Speed or velocity driving in same condition, particular vector is. So in this condition, this forces, the inertia forces will be 0. If I am not producing the acceleration, then my inertia forces will be 0. Then the equation comes to be this mgfr cos theta into 0.5 alpha a, whatever it is. Equation. Now, based on this equation, I will plot the vehicle performance requirement curves. This is basically the graph which require the power and torque required by the vehicle at different inclinations. And what this graph is going to tell? Please. Now, first, the graph is telling that 2000 Newton, and from somewhere down to 2000 Newton, a curve progresses. So this indicates my plane surface. So with a particular mass, with a particular frontal area, with a particular air density, what we have discussed earlier, everything is decided. These are my torque requirements. In 20 km/h, 40 km, 60 km, 80 km, 100 km. With this speed, my torque requirements are this less. When graph indicates 20 km/h, then my torque requirements are less as comparative to graph indicates 80 km/h. then my torque requirements are high. Why? Because the air resistance come here into action. At previous stages, when the velocity is zero, velocity is near to zero, air resistance diminishes. Air resistance is not there in action when velocity is equal to zero. When velocity increases, my air resistance also contributes to my vehicle torque requirements. Clear? Now, this is the situation in plane. Now, suppose a certain inclination is over there. There are different inclination in our daily life through which we are going to introduce ourselves. So these are the not that inclinations. This is the 3% inclination, the 5% inclination. You can say that the 1.5 degree inclination, the 3 degree inclination, the 5 degree inclination, up to 25 degree inclination. Up to 25 degree inclination. So in 25 degree, our torque requirements are this. If my vehicle is loaded with a, suppose 13,500 kg, and it is a truck, and I inclined that truck on 25 degree. So what are its power requirement? So this is the power requirement of the vehicle. We are not putting anything in the vehicle now. We do not put any powertrain in the vehicle. This is the entire vehicle force requirements. We are not considering the power, giving power to the vehicle. We are estimating the power requirements. Clear? Up to now, we are not giving power to the vehicle. We are estimating the power. So for that GVW, we plot a graph for the vehicle power requirements at different inclinations. So what is the significance of power and torque in vehicles? What is the significance? Can anyone tell what is the difference between power and torque, please? What is the difference between power and torque? Suppose करो
पर्टिकुलर टाइम पे बात करते हैं. टॉर्क, ये टॉर्क इस टाइम पे कोई इंजन इस टाइम पे कितना टॉर्क दे रहा है उसकी पावर हो जाती है.
इस टाइम पे
एक टॉर्क देता है किसी टाइम को अगर कंसीडर करते हैं हम.
हाँ जी.
टॉर्क में दो पावर हो जाती है. इस पावर में टॉर्क पे टाइम आता है. टॉर्क में टाइम.
If you want to elaborate this to a layman, then how will you? If a layman will ask me कि साहब देख के बताओ कि गड्डी च पावर है कि टॉर्क है जी, क्योंकि द स्टडी इज अप टू द अंडरस्टैंडिंग. सो व्हाट इज द पावर एंड टॉर्क? मैं देख के किद्दां दस सकदा कि व्हीकल च पावर है या टॉर्क है? सो द बेसिक डिफरेंस इन पावर एंड टॉर्क इज सिंपल एग्जांपल कंसिडर करते हैं. सपोज मैं किसी दे थप्पड़ मारिया, किन्नी जोर के मारिया, दिस इज माई टॉर्क. किन्नी जोर के 5 मिनट च किन्नी बार मारिया, दिस इज माई पावर. उसी एम्पलीट्यूड नु. क्लियर? कि वही टॉर्क में किन्नी बार रिपीट किया विद टाइम. यू आर एब्सोल्युटली करेक्ट. वही टॉर्क नु पर्टिकुलर सेट ऑफ टाइम च मैं किन्नी बार रिपीट किया, दिस इज माई पावर. सो व्हेन वी आर एक्सेलरेटिंग वी नीड मोर पावर. When we are accelerating we need, but when we are starting off then we need more. सीधी गल जे हुण मैं सीधा कहूंगा जी, जे तां व्हीकल थोड़ा पट हुंदा है फिर तां थोड़े व्हीकल च टॉर्क हैगी है. जे थोड़ा व्हीकल एक्सेलरेट नहीं करता तो थोड़े व्हीकल च पावर ही नहीं है जी. जे थोड़ा व्हीकल एक्सेलरेट कर रहे हैं with velocity, then it will have the power. Clear? So this is the basic difference between
हिंदी बोलिए या इंग्लिश बोलिए, क्योंकि समझ में नहीं आता है
sir. So this is our basic engine curves. Now we are going to empower our vehicle. We are giving power to our vehicle. Previously we are estimating the requirements. Now we are giving power to the vehicle. Clear? So we have to select our aggregate on that basis. So when we test our engine in our test lab, then there is a different graphs for torque as well as power. So this is the graph for torque. This is the graph for torque at different RPM. At different RPM, the value of torque increases or decreases. So this is the power requirement. Power generated by the engine. So this is the power curve of the engine. Clear? So the engine which I got to fit my powertrain is of maximum 300 Newton meter, and the power of the engine is up to 200 kilowatt. Clear? So this is my power plant. When installed, the engine will produce less power due to. अब क्या होगा, अब जब हमने इंजन को एक सर्टेन सेट ऑफ टेस्टिंग बेड पे सिमुलेट किया तो उसने एक पावर और टॉर्क का कर्व दे दिया, पर वो इंजन को तो हम व्हीकल में इंटीग्रेट करेंगे. जब व्हीकल में इंटीग्रेट करेंगे तो उसमें अल्टरनेटिव ड्राइव भी लगाएंगे, लाइट भी जलानी है गाड़ी की, उसके बाद आपको ठंडा भी रखना है, एयर कंडीशनर भी लगाएंगे, उसके बाद कूलिंग फैन लॉसेस, वी हैव टू मेंटेन द इंजन टेम्परेचर, फॉर दैट वी हैव टू इंस्टॉल ए कूलिंग फैन. आफ्टर दैट द एयर इनलेट डिप्रेशन ड्यू टू एयर क्लीनर. When we installed air cleaner in engine for the CFD purpose, we find a depression in air inlet. So that also contributes to losses. Air inlet pressure due to altitude. When we increase our vehicle gradient levels, then the air pressure decreases. When the air pressure decreases, then turbo, all that requirements of the engine are differ. So exhaust brake pressure. When we put a exhaust system in the engine, when we are testing the engine on a test bed, then we do not put any exhaust system in the engine. So pump installed for power steering. Right now we are having all the vehicle with power steering. So to drive that power steering, we have to install a hydraulic pump in engine, and it will consume a little bit of power from engine. Then the air compressor. Nowadays all the vehicles are ABS, anti-brake system. So for that we need to install the ABS, or air compressors. Air compressors. Air compressor is basically a power plant to generate air for ABS and other related things. For example, our doors of the buses are now pneumatically operated. For that purpose we need a air compressor. Then we have to calculate the power requirement of air compressor also. Then we add up all these losses and subtracted from the torque and power curves from the engine. what we estimate the power requirement or power produced, actual power produced by the engine for the transmission. As I am a transmission designer, so अब किसी ने भी बोल दिया जी ट्रांसमिशन बनाना है, तो उसकी स्पेसिफिकेशन क्या होंगी, किसके लिए बनाना है, किस इंजन में लगाना है, तो उसको तो कैलकुलेट करना पड़ेगा पहले. Clear? So then how can we amplify the available torque of the engine to reach the working torque limits of vehicle specifications? Now, our torque requirement is in plane area is 200 newtons. My torque requirement to start up, only to start up my vehicle, is 200 Newton meter, near to 200 Newton meter on plane surface. But my engine is going to produce only 300 Newton meter. On test bed situation, on seeing the graph of the engine is only producing the 200 or whatever Newton meters it is producing. Then how I will reach that torque requirements, that force requirements, tractive force requirements? I will amplify the torque. I will amplify the torque with the help of gears. This is a step-by-step method to selecting the components. Otherwise, my engine is only producing the 200 Newton or up to the 22,000 Newton meter initially. Then why we have to install a gearbox in the engine? ਆਪਾਂ ਇੰਡੀਅਨਸ ਦਾ ਪਹਿਲਾਂ ਹੀ ਨਿਕੰਮੇ ਬਹੁਤ ਹੈ, ਕੰਮ ਕਰਨੇ ਦੀ ਆਦਤ ਨਹੀਂ ਹੈ. For that we have to select that why we are amplifying, because our requirement is there. If requirement is there, then we have to do. Clear? And maximum traction available is equal to maximum traction required. अब क्या हुआ, इसमें से क्वेश्चन निकल के आ गया कि अब प्लेन में तो हमने प्लेन में तो टॉर्क, अब हमारे को पास सारा डाटा है कि 25 डिग्री पे कितनी रिक्वायरमेंट्स है पावर की और टॉर्क की, प्लेन सरफेस पे कितनी रिक्वायरमेंट्स है पावर और टॉर्क की. अब ट्रांसमिशन, अब ये भी पता लग गया कि इंजन की क्या रिक्वायरमेंट्स, इंजन क्या प्रोड्यूस कर सकता है. उसके बाद पता लगा कि इसको एम्प्लीफिकेशन के लिए हमें गियर बॉक्स चाहिए. अब एम्प्लीफिकेशन के लिए गियर बॉक्स चाहिए, लेकिन एम्प्लीफिकेशन कहां तक करेंगे, कितनी एम्प्लीफिकेशन के लिए चाहिए? फर्स्ट गियर रेशो क्या होगी? फर्स्ट गियर रेशो इज द मैक्सिमम रेशो, मैक्सिमम एम्प्लीफिकेशन. फर्स्ट गियर रेशो क्या होगी? सो फॉर दैट वी हैव टू परफॉर्म another set of calculations. So maximum traction available from the graph, if I am talking about my first gear, then suppose according to our study we come on a consensus that we have to give 15 degree inclination maximum to a vehicle with GBW. We have to give the 15 degree inclination maximum to the vehicle with that GBW. For 15 degree, this is my power requirements. This is my power requirements. And this power requirement I calculate in the previous max into Tmax or dynamics. This FZA into R dynamic is equal to Imax into Tmax into, and now this is the efficiency of the vehicle. This is the first gear ratio Imax. Then when engine torque is multiplied by gear ratio, when available engine torque is multiplied by the gear ratio with a certain set of efficiency. With a certain set of efficiency, it will be equal to the power requirement of the vehicle at that inclination angle. Clear? So for that, and transmission losses, the new torque which I specified it earlier is new torque is the transmission efficiency. Now transmission efficiency contributes to gear losses. The sliding is over there in the gear, the bearing losses. When we preload the taper roller bearing, have anyone see the taper roller bearing arrangement? Preload taper roller bearing basically in 2 cups. When we preload it, then it will consume a force. Suppose this is a marker, this cup is tight. When I'm going to rotate this cup, it will consume a force. This is a loss. Otherwise, if it is a radial roller bearing, free घूमदा हुंदा, that will consume less force. So in taper roller bearing, there are certain cases in which the forces are introduced, the sealing losses. When we seal a particular shaft, then it will again contributes to losses. The synchronizing losses, the clutch losses, torque converter losses. And selecting the largest powertrain ratio. So as I explained to earlier, the Tmax torque available by the engine multiplied by the first gear and the efficiency of the transmission will be equal to the torque requirement of the vehicle in steady state condition for a particular inclination. Clear? From here, I max is equal to R dynamic mg fr cos theta T max. Hence, from here, we calculate the first gear ratio. Clear? From here, we will calculate the. Now, when I multiply this first gear ratio with my engine curve, so it will produce a graph. If I select the, I have to maintain a 25% inclination, 15 or 20 degree inclination. Then my engine, gearbox, differential tire will make that much of torque, this much of torque, which is equivalent to the power requirement of the vehicle. Clear? Then I am pretty much satisfied that my vehicle will climb up to this much of inclination. Clear? Now, transmission is decided by the final gear ratio and the lowest ratio, top gear ratio. Because we have to maintain a particular center distance for the transmission. So these are the dependable factors on which the transmission, basic building block of the transmission. First, we have to decide the first gear ratio, then the last gear ratio. For the last gear ratio, we have to select our power requirements, the velocity requirements. Generally, we see कई गड्डियां क्या होता 90 के ऊपर जाओ, एक्सेलरेटर दबाओ, गाड़ी एक्सेलरेट ही नहीं करती. 3 बंदे ज्यादा बैठा लो गाड़ी में, गाड़ी का पैडल दबाओ, एक्सेलरेट ही नहीं करती. The powertrain is producing not much amount of torque and power to compensate with the power requirement of the vehicle. 4 बंदे बैठा लिए, GVW इंक्रीज कर दिया गाड़ी का, उसकी जो पावर रिक्वायरमेंट्स कर्व थी वो ऊपर चली गई. फोर्सेस ज्यादा चाहिए, लेकिन पावर ट्रेन तो उतना ही फोर्स और टॉर्क प्रोड्यूस कर रही है. तो उस केस में पेडल दबाई जाओ, व्हीकल विल नॉट एक्सेलरेट, स्टेडी स्टेट हो जाएगा. For that, we need to decide what velocity we need. Generally, in India trend, the maximum velocity is 110 to 120. Clear? By considering this velocity, we design the top gear ratio. We design the. Now this is the power requirement of the vehicle. If my power plant, the power plant which is producing power, decline this curve, then this condition is a non-accelerating condition. This condition is a non-accelerating condition. Up to this point, this is my accelerating condition. So we have to make sure that our vehicle velocity requirements will satisfy with the specified vehicle ratios. Clear? Now we decide our first gear. Now we decide our last gear, top gear. Then how we will distribute these gears in vehicle graph? We have to distribute first gear up. We have to make the first gear, second gear, third gear, fourth gear to reach up to sixth gear, and we have to distribute between first gear and last gear. So there are again certain set of equations which describe what will be our first gear, what will be our distributions within the gear. So these are the three methods: shaft profile diagram, geometrical gear strapping, and progressive gear strapping. So this is the shaft profile diagram. In this diagram, suppose let us take an example. I thoughtfully design a gear ratio in which when I put first gear from second gear, my vehicle stops. My vehicle, let us take an example. If I am accelerating in top gear, I have to change a gear. When I have to apply certain brake, then I have to change a gear from fifth to fourth. Then I faultily put fifth gear to sixth gear, and vehicle will not accelerate. Why? Because engine at that point, the engine is not producing that much of torque. Reason? This is my, suppose, eighth gear. When in seventh gear, the engine is producing at this point 1500 RPM. 1500 RPM, 1500 RPM and seventh gear. When I wrongly put eighth gear in place of seventh gear, then at this, the engine RPM, at this speed, the engine RPM is speed is 100 and engine RPM is 1500. But engine this point is at speed of 75. Vehicle will remain at the speed of 75. But at 75, the engine RPM will decrease up to 1000. Clear? I explain this is, suppose I am in seventh gear. My engine RPM is 1500. And my speed is, you can say that, the 60 degree kilometer per hour. I press a clutch and put wrongly put a gear in sixth gear. नहीं, इसको मैं डिस्ट्रीब्यूट करके बताऊंगा आपको. पहले आप जो इस ग्राफ का जो मोटिव है, इसका मोटिव ये है कि जैसे अब मैं 60 की स्पीड से जा रहा हूं, मैंने एक पर्टिकुलर गियर डाला, उस गियर पे मेरे इंजन आरपीएम 1500 है, यहाँ पे 60 की स्पीड है, मेरे इंजन आरपीएम यहाँ पे नियर अबाउट यहाँ पे 1500 है। अब जब मैं रॉन्गली उसको 7th गियर में डाल दूंगा तो उसकी जो इंजन के आरपीएम है वो कम हो जाएंगे। So we have to maintain that difference within the engine RPM. We have to select the curves in which the engine is going to deliver power, and we have to step the gears like that. We have to maintain the steps in the limits that they will not stall the engine or over speed the engine. How it will overspeed the engine? Suppose I am in first gear. This is my speed. Suppose I am in 6th gear. This is my speed. When I wrongly put 5th gear with this speed, this will be the engine RPM. When I wrongly put a downshift, with downshift my engine RPM increases. If my engine RPM increases, then there is a maximum engine RPM in the engine. We have to maintain that minimum engine RPM and maximum engine RPM. The stall condition, we have to maintain the stall condition. The engine will not stall, reduce. We have to not reduce the engine RPM by gear stepping, or we have to not increase the engine RPM by gear stepping. By calculating this, we have to distribute this gears within a certain set of equations. Clear? Now this is geometrical gear steps. This is the basic formulas which describe how we distribute the gears in geometrical stepping. In this, if we have the higher power if our weight to power requirement is more, as I explained you earlier, the weight to power requirement is more, then we can put a more step over there, more gap over there. If our weight to power requirement is less, then we have to put a small step. So this is again the progressive gear stepping. This stepping is for if our power to weight ratio is more, then we have work accordingly. And this is the way in which all the gears is distributed. This is our power requirement, and this is the power produced by the power plant. So in this graph, we covered everything: the power produced by the power plant and the vehicle power requirements. On that requirement, we select the first gear, the top gear, and we distribute this gears in this graph by a certain set of equations. And from here, we defined the gear ratios of the transmission and a vehicle power requirements. How my vehicle is going to perform with this aggregate. This graph is generated for different vehicles, for cars, for trucks. The requirements are different according to the vehicle requirements, and the engines are according to our engine availability, engine power and torque availability. We have to amplify this power and torque with the use of gearbox, with the use of rear axle and tire to meet that vehicle power requirements. So this is basically you can say that the estimation of the vehicle performance before producing a vehicle. So this was the basic lecture.